Distinguished future physicians, welcome to Stomp on Step 1, the only free video series that helps you study more efficiently by focusing on the highest yield material. On this video, we're going to be covering pedigrees and patterns of genetic inheritance. This is the fourth video in my genetics section, which has 7 total videos. I suggest you watch the types of genetic inheritance video before you watch this one. Those two are a good combo together, because first I cover different types of genetic inheritance, and then I show you how those types of inheritance are applied to pedigrees. If you don't understand the video before this, you're going to struggle with this one.
You can see here in the top right corner that I give pedigrees a high yield rating of 9. For those of you who do not know what that is, the high yield rating is a scale from 0 to 10, giving you a rough estimate for how important each topic is for the Step 1 exam. And if you'd like to learn more about how the high yield rating is calculated, you can head to my website here.
Pedigrees are graphical representations of ancestry within a certain family related to one or more diseases. Most pedigrees will have a square for males and circles for females. And then the black or filled in shape is going to be an individual that's affected by the disease, and the empty or white shape is going to be the individual who does not have the disease. These individuals with the empty shape could still be a carrier. You're not sure about that. Occasionally there will be a certain type of pedigree where the shape has a line down the middle and it's half empty, half filled in. That means they're a carrier, but that's not as common as these more standard shapes. Each generation in the family is a given row, and usually you're going to number those rows and the specific individuals with Roman numerals, so you could refer to somebody specific in the ancestry based on some sort of numbering label. Here is our first pedigree. So this pedigree started with one couple. You can see up here we've got the grandmother and grandfather, and the grandfather was affected by the disease and the grandmother was not. As you go down to their children, they had 4 kids. They had 1 boy and 1 girl affected, and 1 boy and 1 girl not affected. 2 of their children went on to start families of their own. The affected female ended up having 2 affected children, and the unaffected female who started her own family ended up having no affected children. So have you figured out what type of inheritance this pedigree is for yet? Well, let's try to walk through it step by step. First off, you'll see that there's a lot of individuals affected. Every generation has somebody who has the disease. That's one clue. The next clue is that males and females are affected at about the same rate. You can also see that the disease can be inherited from the mother or the father, because from the first generation to the second generation, you have the dad passing it on to kids, and then from the second generation to the third generation, you have a affected mother passing it on to the kids. Given those hints, we know it's going to be autosomal dominant inheritance for whatever disease is depicted. And to review, you're going to see most generations have at least one individual affected. The disease can be inherited from mom or dad. Males and females are affected at about the same rate, and you can't inherit an autosomal dominant disease from an unaffected parent. We went through the Punnett square stuff a little bit with the last video, but just to review here, if you have a heterozygous affected parent and one unaffected parent, 50% of the kids, male or female, doesn't matter, are going to have the disease. If you have 2 parents that are heterozygous and affected, you're going to have 75% of the kids have the disease. And then if you have 1 homozygous affected parent, 100% of the kids are going to be affected, even if the other parent is homozygous unaffected. Here's another pedigree we can work through and try to figure out what type of inheritance it is. First, you're going to see that the disease doesn't affect every generation. There's only 1 individual here in these 3 generations affected. The other thing you'll notice is that you can inherit this disease from 2 unaffected parents. Those are pretty big hints to let you know that it is autosomal recessive. So to review, it can be affected from unaffected parents. Males and females are going to be affected at the same rate, but sometimes it's hard to tell. Like previously, there was only one affected individual, but I specifically made it an affected female to differentiate it from X-linked recessive, which we'll do later. And few generations are going to be affected, probably, unless you've got huge families. So if you have one parent who's unaffected carrier and one parent who's homozygous unaffected, 0% of the kids are going to have it. If you've got two heterozygous carrier parents for an autosomal recessive disease, 25% of their kids will have the disease. And if you've got one homozygous affected parent and one heterozygous carrier parent, 50% of the kids are going to have the disease. Here is another pedigree. First, you'll recognize that this disease can be inherited from two unaffected parents. That lets us know it's recessive. And then you're going to see males seem to be affected more than females. Given those two hints, we know it's X-linked recessive. Because males are affected more than females, it can be inherited from unaffected parents. And something that's a little trickier to see on pedigrees is that sons can only inherit it from their mother. A son can't get an X-linked recessive disease from their dad, because to be a boy, the son has to inherit the Y chromosome from the dad. So a father can pass on an affected X to a daughter, but not to a son. So 0% of sons are going to be affected if the dad is affected. 50% of the sons are going to be affected if the mom is a carrier, and 100% of sons will be affected if the mom is affected herself. Here's one more type of pedigree. You can see here that entire generations are affected. That's a big hint there. Males and females are going to be affected. And it looks like it's only inherited through the mother, because we see bottom right here, an affected father has no children with the disease, but both times there was an affected mother, all of the kids had the disease. So that lets us know it's mitochondrial inheritance. In this case, you're only inheriting the disease from your mom. Your dad's status has no effect on the disease. Males and females are affected at the same rate, and all offspring of the affected mother are affected. So if your dad is affected, you have a 0% chance of having the disease. And if your mom's affected, you have a 100% chance of getting the disease. Pretty simple. If your mama got it, then you got it. End of story. I was able to put pretty much all the info I've covered over the last few slides onto one big table to help you compare and contrast these four main types of inheritance, but you probably can't really read it on here. The text is pretty small. I couldn't figure out a way to cram it all into one slide, but I will make that table available on my website, so you can go there if you'd like to get this table.
That brings us to the end of this video. If you liked it and you want me to make more, please like my videos on YouTube and subscribe to my YouTube channel. I won't bore you with the details about search engine optimization or social proof, but just know that even though it only takes you a couple seconds to do those things, it really helps me out a lot.